Hello all, welcome to Java programming from CodeBae. In this video, we'll be discussing about OOP concepts. We'll be discussing in detail about what is class, what is object, what is inheritance, what is data abstraction, encapsulation, and polymorphism. When talking about any object-oriented programming language, it has to support all the above features like abstraction, encapsulation, polymorphism, inheritance, class, and object. Abstraction and encapsulation can be achieved. They both can be achieved with the help of classes, objects, and some visibility controls. That means these visibility controls are helping us to control the visibility of the data of a problem. Polymorphism. Polymorphism can be of two types. It can be of static polymorphism. It can be of dynamic polymorphism. Whereas inheritance can be of single level inheritance, multi-level inheritance, hierarchical inheritance. We'll be discussing in the coming sessions how they can be achieved with the help of programming. Now let's discuss or let's understand these concepts. Object. Object is called as an instance of a class. Object is defined as an instance of a class, which has a unique identity. Every object will have a unique identity, a state, and a behavior. State is defined or specified by the variables, whereas behavior is defined by methods. And these variables or methods are shared to the objects with the help of a class. So object is an instance of a class which has unique identity, state, and behavior. Objects can also be treated or considered as physical units. They can also be considered as physical units. Now let's see what is an object. If you can see here a ball which is made up of a leather football. That means this is specifying the identity or the type. Sorry, this is specifying the type. What type of the ball? Is it made of a leather? Is it made up of a cork? So that is the type of the ball. That tells you about the state. That tells you about the state. And every ball has a certain functionality. Some ball is very hard, which does not bounce much. Some ball can bounce much. So that defines the behavior. So here the ball is rolling. So that is the behavior of the ball. So bouncing, rolling, these are all can be considered as a functionality of the ball. If you can see these two, yellow color and the red color, one is made up of a tennis ball, the other one is a leather ball. So one is a cricket ball and next one is a football. So we have a unique identity for every ball. So this tells the identity. So the make of the ball defines the state. So this ball is made up of leather. So this defines the state. And rolling, rolls is the behavior. And name, football, cricket ball, tennis ball, the name defines the identity. So how you are identifying the object. So this ball can be treated as an object. That means you can touch it, you can feel it. That is a physical thing. Right? So this is all about an object. Class. Class is a mold. This is your textbook definition. Class is a mold or a template or a blueprint which is used to create objects. So if I need to have objects, I need to have classes. Classes are used to create objects. A class is a set of objects. That means a single class can have multiple objects, as many as objects, which shares the common structure and behavior with the objects. Every class shares its structure and behavior with the objects. Class also contains the state and behavior. This state and behavior is shared with the objects. So as we have discussed, state is defined by the variables and behavior is defined by the methods. And the other point is the state or the variables are not exposed to the global or not globally exposed or not globally exposed, but whereas methods are exposed, globally exposed. Or we can also say that variables are not exposed to the outside world, methods are exposed to the outside world. This is about a class. So let's have some real-time example of a class. If we say vehicle is a class, then truck, all these type of vehicles are the objects. What is the functionality of a vehicle? It is used for the mode of a transport to travel from source to destination. Take any vehicle that is used for a certain movement. What are the properties that the vehicles are having? What are the properties this particular class is having? It is sharing all its properties, that is its state and behavior, with all the objects. That is what we have discussed with the class. We have seen that class is a set of objects that shares the common structure and behavior with the objects. So even in this case, if I'm assuming the vehicle as a class, it is sharing all its properties with the help of objects. It is sharing all its properties to the objects. This is about a class. Now coming to the other concept called abstraction. This is something more important feature of an object-oriented programming language. The major purpose of an abstraction is exposing the essential details and hiding the non-essential details. That means we hide the logic and expose the user interface. So abstraction can also be defined as separation of logic and user interface. Abstraction is a process of separation of logic and user interface. So logic is something which is not essential for the users. Users are not bothered about what is the code that is written, how is it function. So logic is not essential with respect to the user. So we hide the logic and we only expose the functionality with the help of user interface. This kind of programming is called abstraction. That means if you just look at your computer, we have all kinds of hardware components in it. When we press a key or when we press a certain key on the keyboard, a certain functionality will happen. So we are not bothered about how is that functionality happen. We are only given with the keys which are called as a user interface. When we interact on those keys, another functionality or the logic will be executed. This kind of program is called data abstraction. The major advantage of data abstraction is it simplifies the understanding and using of any complex system. This is the major advantage of having the abstraction. For example, if you just take a switch, we can whenever we switch on the switch, the wires inside will be connected and the power will be posed. Whenever switch on, the wires will be separated. If the switch is not there and if we need to keep on connecting the wires to switch on and disconnect the wires to switch off, it would be very complex for us to do it. So it is not user-friendly application. So when we give a switch, that is called a user interface, that we hide the logic and the user can only communicate with the switches and perform the functionality. So the two major advantages of abstraction, that is simplifying the understanding and using of any application, that is we are indirectly developing an user-friendly application with the help of abstraction. Now coming to the next concept called encapsulation. Wrapping up of data into a single unit is called encapsulation. Wrapping up of data into a single unit is called encapsulation. And this single unit is called class. That means whatever the data that we write in Java, we write only within the class block. If we just look at the English, so N, that means in a capsule, right? So whole data, whatever the data that we are writing in a class, we are wrapping up into a single unit, and that unit is called class. And the advantage of having encapsulation is information hiding and localizing of information within an object. As we have already discussed, what are the variables that we are using, they are not exposed to the outside world. That is localization of the data. That can be achieved with the help of encapsulation. Just look at the real-time example of it. It's, if you can see, this is your motherboard. We have all kinds of devices that are there, like RAM, CMOS battery, hard disk, everything are connected to the motherboard. All the input and output devices. We only see the cabinet. We only see the cabinet, that we call it as CPU. We only say this. But the major thing that is making all the operations is this motherboard. So what are the functionalities, what are the data that is there, that is being encapsulated here, and we are using the CPU as an UI. So this process is called encapsulation, hiding the data. We are not exposing the data. Whatever that is exposed, that is only the UI. This is called encapsulation. Inheritance. Acquiring the properties of one class into another class is called inheritance. When we want to share the properties or the functionalities of one class into another class, then we use the concept of inheritance. That means inheritance also achieves you reusability, where the classes share the common structure or behavior with one more class. The major advantage of inheritance is code reusability. We will learn in detail about inheritance, but the class which is sharing the properties is called the base class, and the class which is acquiring the properties or inheriting the properties is called the derived class. Base class can also be called as parent class, and derived class can also be called as child class. So inheritance is sharing the properties of one class with one or more classes. This is called your inheritance. As we have already discussed this example, if we are assuming vehicle is as a class, then it shares all its properties with different classes. So we have another class called land vehicle, we have another class called water vehicle, we have another class called air vehicle, right? So this becomes your object. Land vehicle is inherited again into a road vehicle and rail vehicle. So again, these are the different kinds of objects. So the base class or the parent class is your vehicle. This becomes your parent class, and this is sharing all its properties with different kinds of classes. So it's not necessary for us to rewrite the code. Whatever the code or the functionality that is written in this class can be reused in all the different classes which are inherited from a class called vehicle. This is the advantage of having inheritance. And the other important feature and the last important feature of an OOP concept is polymorphism. Polymorphism refers to an object's ability to behave differently depending on its type. That means It refers to an object's ability to behave differently in different contexts. When the same object performs different functionality or different behavior in different contexts, that kind of nature is called polymorphism. The most common example, and if you can really can understand easily what exactly the polymorphism is, when you're using a Word document, you can see something called save as, which is used to save the Word file. When you click on save file, you can see different options. Different options will be displayed, like Excel workbook, like save as binary workbook, Excel 2003, or in different formats in PDF format. You can also see in PDF format. You can also see in rich text format or text format. We can select any one of the option. For example, if I'm clicking save as and save PDF and selecting the option as PDF, then the Word file will be saved as PDF. If I click on save as and clicking or selecting the option called Excel 97 2003, then it will be saved in this particular format. If I click on save as and click on rich text, then it will be saved in rich text format. The single function that is save as, this is the operation that we are using, that is save as, which is helping to give different kinds of output file. It might give you a PDF file, it might give you a rich text file, it might give you a text file, or it might give you a Word file, or it might give you an Excel file. These are all the different functionalities that we have for the single save as function. So depending upon the option that you select here, the save as function will behave. This kind of nature is called polymorphism, where a single function behaving differently in different context. This is called polymorphism, polymorphic nature. So polymorphism can be static and dynamic. So dynamic. In the coming sessions, when we discuss about polymorphism, we will see how to achieve static polymorphism and how to achieve dynamic polymorphism. Hope you're all clear with OOP concepts like class. What is a class? What is an object? What is the use of abstraction? How it is helping the programmers to develop user-friendly applications? How is polymorphism useful and inheritance? In the next session, we'll be discussing about anatomy of Java, like comments, identifiers, blocks, and also variables and data types. Thank you all. Thank you for watching our video.